Now let's discuss NVM API configuration class 3. This is the last class in the set of APIs we have discussed, and as a result here we will have all APIs available. Therefore, maximum functionality supported. If you see the table, you can see that all the previous APIs that we have discussed are already present, and on top of that we are getting 3 more new APIs, and they are present in type 1 and type 2. So together we get the maximum functionality out of. And this is the most complex configuration class which rich variety of APIs available to use. So let's discuss about these 3 new APIs in this configuration class. The first API is NVM set block protection. The parameters passed are block ID and protection enabled parameter. So it's a synchronous API of type 1 and it is used to reset the write protection of an NVRAM block. So if you remember, we are able to set the write protection, right? So using this API, we will be able to manually or using code, we can actually set the block protection so that the write can be prevented or any modification can be prevented. The block ID is passed as argument which identifies which is the NVRAM block descriptor we are mentioning about. So for a particular block, we will have to call that block ID for that block. Now, if the second parameter protection enabled, if it is true, it means that write protection is enabled for that block. Similarly, if protection enabled is false, then write protection is disabled. So this function NVM set block protection shall not change write protection of NV blocks with this NVM write block once equal to true. So basically, if there is some block which has this parameter NVM write block once equal to true, then we will not be able to modify its write protection using this API, because NVM write block once means it has its own way of write protection mechanism. So we shall not be able to change the write protection of such blocks. The next API is NVM erase NV block, and the parameter is block ID. It's an asynchronous API and it's of type 2. And this, as in the name you can see, is used to erase an NV block. The argument that is passed, block ID, is what identifies the NVRAM block descriptor. Please note that in this case, we are not modifying the RAM block. We are directly performing the erase on the NV memory. But we are not, the RAM block is not modified in this case. Okay. And finally, we can perform erase only if the block is not write protected. Okay, so if some block is already protected, we cannot go for the erase block operation in that block. The last API is NVM invalidate NV block, and the parameter is block ID. It's of asynchronous type and it's type 2. This API is used to invalidate an NV block. So what is invalidating or validating? It's basically setting the RAM block state, and that will be the next lecture we will be discussing. So for now, just understand that we'll be able to validate or invalidate the RAM block, and this API will help us to do that. The block ID is passed as argument which identifies the NVRAM block descriptor. Again, the block ID is used for the same purpose. Which block we need to perform the invalidation of RAM block, that can be done using this invalidate NV block. Now note that the RAM block is not modified here. Again, we are dealing with NV memory. So not the RAM block is not modified. Also, this invalidation can be only performed if the block is not write protected. We cannot uh, do this invalidation if the block is write protected. Okay. So that's all about the different API configuration classes. So let's summarize. In the previous lectures, we have discussed the different APIs that are available for NVM. The first module or the first API that we discussed is the API configuration class 1. If you remember, this is having basic API support. It doesn't have the extended APIs or the additional APIs that are seen in the other classes. And also we saw that the main APIs that are used from here as the NVM read all, NVM write all. These are the most important ones in this class. The next one we discussed is the API configuration class 2. Here we get the additional APIs such as NVM read block, write block, etc., which will help us to go from multi-block to now single block kind of request and writing. Finally, we discussed this API configuration class 3, where we are able to erase and, for example, to invalidate RAM block, etc. So, depending on our requirement in our project and the hardware availability, so we can decide which is the API class which we need in our project, and thus we can configure it for the corresponding requirement.